Alright guys, now we're doing section 8.6, perimeters and areas of similar figures. So our objective is to find the perimeters and areas of similar figures using proportions. So here's our theorem. It says if the similarity ratio of two figures is A over B, which is what we normally have. We have some sort of fraction. So we have A over B, then the ratio of their perimeters is still A over B. So notice that my similarity ratio and my perimeter ratio is the same. But when we go to area, it is A squared over B squared. So our ratio for our proportion for areas is going to be our side or similarity squared, our similarity ratio squared. So now let's put this into practice. The first thing is I have a rectangle. So I have this side being 6 and this side being 9. So my similarity ratio is 6 over 9 or 2/3. Now remember that our ratio for our perimeters is the same as our similarity ratio. So this is also going to be 6 over 9 or 2/3. Now, when I look at finding the ratio of my area, remember that my area ratio is going to be squared. So I'm going to have 2 squared over 3 squared from my for my areas. So I have 2 squared, which is 4, over 3 squared, which is 9. So my area ratio is going to be 4 over 9. Now, as we do these problems, we're going to write out all the different ratios in order to make our life easier. So it says find the ratio from large to small. So I'm going to start with my large on top and my small on bottom of the perimeters and their areas. So first I'm going to start out with my similarity ratio. So I have similarity ratio, which is just picking two sides. So if I have my two triangles, I'm going to pick my two smallest sides, so then I have to do less reducing or maybe no reducing. So here's my small side for this triangle, and here's my small side for this triangle. So I know my similarity ratio is 4 over 5. Now, my perimeter ratio, remember, is the same as my similarity ratio. So my perimeter ratio is also 4 over 5. Now, my area ratio, which is the last one, is A squared over B squared. So it's going to be 4 squared over 5 squared. And 4 squared is 16. And 5 squared is 25. So my area ratio is 16 over 25. Now the next example, it says, if the area of the small triangle is 30 centimeters squared, what is the area of the larger triangle? So this is where it starts to get a little bit different. I'm going to go ahead and write 30 centimeters squared in my small triangle so that I know exactly what I'm looking at in my pictures. So first thing we're going to do is make our similarity ratio. So I have my similarity, which is just 8 over 12, which is equal to 2/3. Now I can set up my perimeter ratio, which is also 2/3. So perimeter So the last one we need is our area, because we're going to be trying to solve for area. So I have my area ratio, which is going to be 2 squared over 3 squared. And 2 squared is 4, 3 squared is 9. So now this is my ratio of how much this is going to change. So now I can set up my proportion. Now, my proportion is going to be 4 over 9 is equal to something. So I have my area ratio, which is 4 over 9. And that is equal to, we're going to say 30 over x, because we don't know what the area of this is. So I have to use my area ratio and set it equal to my actual areas. Now notice I have 4 over 9, so I have little over big equals 30 over x, so little over big on both sides. Now I can just continue like normal and cross multiply. So I have 30 times 9, which is 270, is equal to 4x. And then when I divide both sides by 4, I get 67.5 centimeters squared is equal to x. So my area of this triangle is 67.5 centimeters squared. Okay, let's do another one. So I have the areas of two similar pentagons are 32 inches squared and 72 inches squared. What is their similarity ratio and what is the ratio of their perimeters? So now they're telling me my area and I need to find my ratios. So I have my ratios. Remember, area is equal to a squared over b squared. This is my similarity ratio. And I'm going to set this equal to 32 over 72 because that is what my actual numbers are. Now I'm going to reduce this because I need to get this to a over b. And the only way to do that is to square root the both top and bottom. And 32 and 72 are not perfect squares as of right now. So if I divide both of these numbers by 2, then I get a squared over b squared is equal to 16 over 36. Now I can square root every piece. So I get a over b is equal to square root of 16 is 4, square root of 36 is 6. So a over b, this is now my similarity ratio and my perimeter ratio, because remember, similarity ratio and perimeter ratio are the same and they're both a over b. So this is my similarity and perimeter ratio. Perfect. Now, the last example, I want you to try to do it yourself. It works very similar to the example that I did before this on the last slide. And I want you to see if you can come out with the answer. I'm going to tell you the answer, but I want you to try to work it out. So what you should get is a over b is equal to 3 over 5. So you should have your similarity ratio and your perimeter ratio be 3/5. If you do not get this, please figure out where you messed up and come with questions for next class. Have a good night.